Today's lesson we learn reading and interpreting engineering drawings. In the previous 4 lessons, we learned different method of estimating from order of magnitude to unit cost estimate. And especially the unit cost estimate, we need to have a working drawings so that we can do the quantity takeoff. But one of the challenge is how I can read the drawings so that I know the quantity that I take is correct, because define the scope, make sure the scope correct is one of the key point to ensure the accuracies of the estimate. So the first today lesson video, I'm going to introduce the drawings and how to be able to visualize something present in drawings to the physical object that we are going to build. So introduction to plans and specification. How to read plans, so that is ability to visualize the objects to be made from the plan. So basically, this is the from plans. Can I be able to see from that plan it become an object like that, a physical object? That is your ability. So from the plan here, can we see that really something that we want to build this way? So that is the purpose of reading plans. And before we know how to visualize that from the drawings to the physical object, we need to know what are the methods available to project an object on the drawings. Basically, there are 5 different methods: perspective, isometric, cabinet, oblique, and orthographic. And I'm going to briefly present those 5 methods in the next few slides. So you see a perspective presentation. So it's basically a 3D. And with that, just same with our eyes, something is very close in front here. It's bigger, even it's a cube, but it's bigger. Then you show a bigger dimension compared to something farther, then it is smaller. So that just same it the way that we see the object, the closer, the bigger. And the isometric, iso by it, name it blind, it means something equal. So it's also 3D, but to avoid the distortion from the eyes, so we assume if it cubic, then even if far, the dimension all are the same if they have the same length. So that is the isometric. The next one is cabinet. So they have one, for the cubit, one surface parallel to the board or the screen that we have, and the other, of course, form an angles, and that angles form about 45 degrees. And as you can see, the depth, it will be the width. The length here is smaller than the one so on the screen in that cabinet. Similar to cabinet, the oblique, it have similar. They have one surface on the screen, and the other, of course, show the depth, but the angle that they form from the horizontal here is about 30 degrees. So that's the typical difference between those. And that normally we don't use that to present the engineering drawing. The engineering drawing that you see, like 90% of the drawing that you see, if it's not more, in our daily life, in a real project, that is view is orthographic. So instead of put a 3D like perspective, isometric, cabinet, or oblique, we put it in plan view or elevation or front view. So plan view, I just watch this, and then my eyes going down, that is plan view. Elevation view, put it here, and I watch this way, that is elevation view. So that, and whatever we see in there, just present that, and then with that view, and normally combination of a few view, then we can visualize the object, and that is the typical engineering drawings present. So see you what is the difference between different objects with different method of projection. So if we have a half-inch cube, This is perspective, this is isometric, this is cabinet, and this is oblique, and this is orthographic, basically a two square. And with that two square for plan or top view or an elevation view, we can see, oh, that actually a cube. And then we have a box. The way they present also different, as you can see here. And then we have other objects that present differently. But then we focus, like I say, orthographic, because that's typical for engineering drawings. And as you can see here, for the first four methods, perspective, isometric, and oblique, one object present one on the drawing. But for the orthographic, it can be present more than one, and that is a challenge. So it is necessary for your ability to not read only focus on one drawings, but we have to be able to coordinate between the drawings so that we can visualize what is that physical object should be. Okay, so that is the challenge of the orthographic. So try let stop the video, pause the video, and I want you to draw by yourself with the orthographic projection, the last method we mentioned. Draw the front view, and then the top view, bottom view, left view, right view, and rear view of this object. So this is the object. So let's pause this video and try yourself on your paper, and you see what it look like. So for the front view, basically what you see in the screen here, that will be the front view. Top view, on top, look down to that object, and then bottom view, look up. Left view, look from left. Right view, from right. And then rear view, from just back of the screen, go up here. So draw yourself, and then I'm going to show the next one. To draw that, basically how people do, they call it glass box. Put that in the glass box, and I have a box here to show you. This is mine, and this is my Christmas box. It's not Christmas today. So here, put in the box. So whatever the shape, the project of that object in different face of the box, it will be the view that we have. For example, if we project to, yes, it will be top view. If whatever, it put it down here, bottom view, left view, right view, rear view, front view. So that those are the one that you have in the box. Whatever this object go down and it project to different surface of the box, it will become a view that for that respective direction. So with that one, if I open the box, take out, we will see that. You see that, and as you can see, the box have 6 sides, right? 6 sides in here, and that different box have different side, have different view on that one. So front view, if we look at front, we can see that object in here, and the right side here, you can see the light, 1 light, 2 light, and 3 light. That's why we have it here, because we see on the light, then it will be solid. And then rear view from the back of your screen, go back here, you see that one. And left view, whatever we see here, just only one surface, and that intersection here behind the left, I don't see it, so I put it in the hidden light. And similarly for the bottom, I see only the surface. This one, a hidden line, that the intersection here, that if I look at from top, I can see that line, but on the bottom, I don't see it, then I put that hidden line. So those are the way to present an object. So with this view, you can be able to visualize, oh, wow, this is the object I want to build. And that just show you some how view if it top, then the eye of people on top and look at it, it will see that way. That's what we have. Front view, this is what I'm going to see, and that here. And then side view, this is what I'm going to see that object. So those are the way to present in orthographic views, and you should be able to present a simple object. And then after today class, you need to be able to read the drawings with the more complex object that people present, engineer, design, present in drawings, and how to visualize that by do a correct quantity checkup. So from that, and with that three different view, top view, front view, and side view, pause this and look at and tell me what should the object of this one look like with only three views. Can we visualize that one? After you pause, you can see if you're correct that it will be that object in real life. So whatever this object here, and then there is a hole in that area, so go through this one, and that is the hole here. Okay, so and it's hidden because the hole, if you look at here, we don't see it, so we put in hidden line. It means the dash line in there. So that here with the hole in that, so and that present with the top, front, and side view. So we talk a little bit about the hidden line with the dash, etc. But there are many other time applies, and when you present the drawing, you need to be able to use the format of the line properly. First, visible light, then it will be thick and solid. Hidden line, something we don't see, but we want to visualize it, so it will be thin and dash. Center line, just like we have a circle, and circle have a center. If we want to show that in the center, then we put that center line thin in here. If tension or dimension line, we show the dimension, how is the width of this object, then that the dimension line, it should be thin. So it have to contrast the thickness and then also the time of the light that we have. And then cutting plane, if we want to show, cut this in the middle or in here, want to see what it go and what my view should be, this arrow show the view I have. If I cut this one into two parts and I want to see this part, then the arrow go this way. If I want to see this part, go the other way. So that arrow show which view you are looking at. You look to the camera or from the camera, look back to me. Section light, if you make a cut. Break light, for short break, just like if something like you have continue but you don't want to show because it's a linear, the same repetition, then you can make that for short break. But if it's something long, then you could put things like you draw a transmission line or water supply, and it's the same pipe for a few miles. You may make a break line for that, just to condense in because the limit size of the drawings. And then phantom light, we will show that in the next slide. What is phantom? So different type of light we talk in here, but the one that I want to emphasize in here, the phantom light. So for example, you focus on this part, the solid part here, but that part is a component in a bigger system. Then maybe someone else going to do this, not you. We only do this one. So we want to see that if someone else does and we provide this, it fit together nicely. For example, here I want to do this blue, someone will do this red and put it nicely, but I focus on here, so I put a solid line. Oh, but I think that if someone will do it and be able to put in my blue cube, so that we can show the phantom light may out not in scope of my work. Or maybe for future development, you can use phantom light. So go back to the plan and specification for the set of plan that we have it in here, and that is the worksheet 6 reference. You have to use that to do the quantity takeoff for today. And what is typical, they have it in there. The first, the cover sheet, general note, when it's general G, the drawing, they put it G. Civil drawings C. So when you have start the drawing number C, then it's civil drawing. Architectural drawings A. Structural drawings S. Mechanical drawings M. Electrical drawings E. Piping and instrumentation drawing diagrams P and ID. And specification also have detailed information that cannot be provided in drawings because you cannot put all the text, all the word in this one, then you refer to specification. For example, if we have here another drawing that you have a chance to do. So if we have a tank, something like that, then if we put everything, who provided, what is the steel material here, what is the pumping, etc., that it will be too much work then on the drawing. So they put it in specification, and that it should be more detail, more information about the something that present in the drawings. So for now, you need to be able to know when the drawing that's in the number drawing starts with C, civil, architectural A, structural S, mechanical, electrical, piping, and instrumentation diagram. And there are many other, if needed, we can have that. So for example, P and ID is mean piping and instrumentation diagrams. For those of you, for example, work in environmental engineering major, so you have that a lot in here, so that normally your process, for example here, present with the P and ID, how the process work, etc. In terms of drawing size to present, so we have here our system, US system, and metric size, so it try to be equivalent, not exactly the same size. We use letter, everyone know that, and that is A4 in and in millimeter in metric size. And normally engineering drawing to be easy to carry, we do with the B, so 11 by 17, so that is the 11 by 17, and that is B, equivalent A3 in a metric system, and etc. that you have all the sizes we have for drawing side. Drawing general information, normally you have what is title block, revision block, abbreviation, and legend. I'm going to show that in drawing here before we try this, and then we go to drawing. In the next video, I show you what those information we learn here and how that work in the drawing that I show in the reference in the worksheet that we going to use for the quantity takeoff into